Good morning, good afternoon, good evening, everyone. Welcome back. In this part of the presentation, we will dive into the technical implementation of the Snowflake solution, focusing on how dynamic tables are used to unify and transform Salesforce data into a single scalable data set. With this foundation, we're now ready to showcase the technical implementation in Snowflake. Let's take a closer look at how these dynamic tables are defined and how they work together to deliver a seamless solution. Let's start by revisiting the challenge. Unified data is where we solve the fundamental problem of combining two structurally different data sources. Let me break it down what's happening here and why it's critical. We have two tables that represent the same business entity but with different characteristics. The contact snapshot table contains all fields for all records, refreshed completely on a schedule. Contact CDC contains only the fields that changed in each event. It streams in real time as changes happen, missing many fields that exist in a snapshot, and has a CDC specific metadata-like change event header that tells the type of change, whether it's an update, delete, insert, or create, and also the fields that change. So as you can see here, we run this query and where the source type is equal to snapshot. You say that the change event header change field is null. That value is not being populated for the snapshot. But if we run the same query and change the data source type to CDC, we're going to see that that value now is being populated. That's one of the major difference between these two objects. So let's go in more detail and why this layer is so important. So we layer one, or the unified table, we are accomplishing three things. One is field alignment, two is metadata harmonization, and three is data type consistency, right? Without those three components, creating this union would not be possible. So that's the key, right? That's the key element of this layer, right? It's basically that, having that harmonization, right? Having a consistent schema. Every record has the same number of columns now. Source traceability. We have a data source type that tells us the origin of that particular record, and we have a clean foundation that leads out into the dynamic table, what I call the transformed data. So this layer, this is not just a simple union, it's a structured harmonization that makes the entire data pipeline possible. This is really the building block. This unified table is the building block that makes the entire pipeline possible. So dynamic table 2, the transform contact data. Here's where we apply the forward field logic, and we create a hash-based change detection. So basically the technical accomplishment is data continuity. CDC events inherit previous values for unchanged fields, and we use Windows functions, lag with ignored nulls to ensure complete records. And then we create a hash, and me scroll down to the hash area. We create this hash-based change detection, right? To see if we've seen the record before, to actually do the deduplication, right? We use the forward field logic when combined with equal is, as you can see here, for the missing CDC values. And what we're doing here, what we're accomplishing here, is a technique used to input missing values, nulls, in a data set by carrying forward the last observed non-null value. This is particularly handy in time series data or in any ordered data where the previous value is a reasonable substitute for a missing value. This is what we're doing here, and it's a very important step. And the final step, as you can see, is that deduplicate elimination. We compare current versus previous. Let me scroll down. We compare current versus the previous hash to identify the true changes, and these allow us to really capture real changes. So dynamic table 3 is the contact history. This table is basically what it's doing is showing the historical evolution of a single contact record. Will powerfully demonstrate the audit trail and the time travel capabilities that this particular pipeline provides. I have a query that will showcase this in a bit. But basically, the key technical point this historical table is accomplishing is a complete audit trail. Every change is preserved with a timestamp. We can reconstruct contact state at any point in time, and we also have the forward field logic in action, where CDC events only contain change fields and the pipeline fields missing fields from previous version. And so the end result of this is a complete record at every point in time, and that's what we're accomplishing this layer. Without this pipeline, without this layer, CDC events will be sparse, and we will lose historical context. But with this pipeline, we have a complete audit trail of every single record. This is, let me show you a quick query of what this means, right? So if we go to the CDC event analysis tab, you can see that we have a version number, we have the change timestamp, the Kafka event time type, the data source type, and the record hash. So for this particular record, it has 6 entries. It went through 6 changes, right? So the first one obviously is a snapshot, because is the first time we've seen that record. It's being loaded via the snapshot, but then it's via the CDC. So, and you can see that the timestamp events are how they change. So this is how you build that historical picture of a contact. Layer 3 give you that historical evolution of the record, right? And with this historical evolution of the record, you can answer any question, right? You can answer, what was John's address on March 15 of 2022? When did he get assigned to a particular project? Or when was, what's the complete timeline of his project? So this is what that historical view give you, right? It's a nice representation, evolution of that particular record, right? So this is it, guys. Thank you so much for watching, and again, please, send me an email. My email is at the end of the presentation. And again, this is a simple and elegant architecture leveraging the power of a Snowflake Dynamic Tables. It's all possible, using Snowflake capabilities. So thank you very much for watching, and if you like it, subscribe to my channel.